Good afternoon, everybody. Thanks for coming. Let's go ahead and get started. My name is Max Ross, and today we're going to be talking about testing techniques for Google App Engine. Quick reminder, you can follow along with some live notes that are being taken on this wave here. I'll give you all a second to type that in. We have a moderator module there, so you can ask questions at the end. OK, so a little bit about me. I'm a software engineer at Google. I work on the App Engine team. I do things related to persistence. I work on the data store. I work on the JPA and JDO implementations that ship with the Java SDK. I do various things related to the Java runtime. The most important thing that you need to know about me with respect to this talk, though, is that I take testing very, very, very seriously. I love writing tests. Tests make me feel good. They let me sleep well at night, and I hope that makes you feel good knowing that a storage guy on the App Engine team feels this way. Brief overview of what we're going to cover. I want to spend a few minutes talking to you about developer testing in general, and then we're going to talk about some techniques for testing your App Engine apps locally using the App Engine SDK. And then we're going to get a little bit more adventurous, and we're going to talk about techniques for running your tests in the cloud. And I've got some really, really cool demos planned that I think you're going to like. Then we'll wrap things up, and then I'll take any questions that you might have. So let's start with developer testing. I want to define a couple of terms that I'm going to use over and over. There's a lot of language around testing. There's disagreements about the definitions of these terms. I want to give you my definition so that when I talk about an integration test or a unit test, you know what I'm talking about. I apologize if you disagree with these. A unit test, we're testing something very small, something very precise. No external dependencies. Or if there are external dependencies, we're in complete control of them. A classic example might be a string parsing routine, where all of the logic is included in just that single function. You want to make sure it does what you expect it to do. We can expand the scope a little bit to an integration test, where we're testing the interaction between components, or maybe even systems. Classic example here, writing tests that talk to a database or a data store. If you're working on App Engine, you want to issue a query, or really put some data in the database, issue a query, make sure you get back what you expect. And I'm going to show you some live demos of that in action. And then expanding the scope all the way out, we have end-to-end testing, where you're driving your application through the public API. For App Engine, this means HTTP. Classic example here might be verifying the authorization flow of your application, where you go to a particular URL, you don't have permission to look at it, an admin logs in, they give you permission to look at it, you visit it again, you see that the page renders. So I need to get up on my soapbox just for a few minutes here and let you know why I am so passionate about developer testing. The obvious benefit here is you write some code, you've added some functionality, now you want to make sure that it does what it does. You want to make sure it does what you expect it to do. You write a test, you test that code, you check that code in along with the test. It gives you a good feeling about the code that you've just written. And that's important, and that's valuable. But for me, that's not even the most important thing that developer testing gets you. When you're just starting out on a project, checking code in is not particularly risky, because you're not at risk of breaking anything. You haven't even built anything yet. So that first check-in, you wrote a test to make sure that that first check-in does what you wanted it to do, and you feel good about that, and you check it in. But that second check-in is a little bit riskier, because there's existing code. There's existing features. There are users that have expectations of this code now. So that second check-in, you're not only in danger of getting the initial thing wrong, you're in danger of breaking the first thing. And the third check-in is riskier, and the fourth check-in is riskier. And now we fast forward 3 years into your project, and you've had 50 developers. How can you actually feel safe about the changes you're making when there's so much at stake with every single check-in? It's actually terrifying, right? But if you're writing tests along the way, you're mitigating that risk. Each check-in is not riskier, because every time you check in, you're adding some code to your code base. It's part of your code base that verifies that what you just checked in does what you wanted it to do. And as long as you're running those tests every step of the way, you never have to lose that confidence. So this makes me feel really good about my code. So the advice that I want to give to everybody in the audience today, if you're not already doing testing, please try it out. See if it works for you. The benefits are real. This is a short-term investment in the success of your project, but it's also, more importantly, a long-term investment in the success of your project. Treat your code as first-class citizens in your code base, right alongside the production code. They deserve it. I'm not the only one at Google who feels this way. Testing at Google has a long and proud history. We take testing very, very seriously. I've listed up here a couple of frameworks that have come out of Google engineering that are related to testing. There's a number of C++ frameworks, which are basically the C++ testing frameworks that we use internally. There's a couple of Java frameworks, one really interesting one, which is useful for concurrency testing. This is an example of how seriously we take it, that the tools that we develop inside, we've released and open sourced whenever we can. We want everybody to have these same tools at their disposal. So how does this relate to App Engine? When we talk about App Engine and where our code runs, we're typically talking about two different execution environments. There's the cloud, where our code actually lives, serving requests on the internet. And then there's the dev app server, which is running locally, which gives us the same functionality that we have in the cloud, but not the same scale. There's actually a third environment that we pretty much never talk about, but we should, and that's what we're talking about here today. It's the test execution environment. The test execution environment can exist locally, and it can exist in the cloud. It can be serving HTTP requests, but more interestingly, for the purposes of this talk, it can also involve a test harness issuing requests to very precise pieces of your code. So the question is, do we need App Engine-specific testing strategies? And the answer is yes, we do need some, and that's what we're going to go over. So let's start with locally, because this is a little bit more familiar. How many people here have written an App Engine application and written some tests that run locally? OK, very happy to see all of those hands. Good. Hopefully, those of you who raised your hands will agree with me that a lot of it is the same. Your frameworks apply, JUnit, PyUnit. You want to write Selenium tests. These things work. There's not a whole lot that's different. The best practices make sense as well in terms of isolation, in terms of how you're going to design your application so that it can be tested, in terms of how you're going to write your tests so that they're effective and isolated and not flaky. This is all really good news. What's different? Not a lot, but there are some interesting technical details that I want to get into. The main one is that the RPC layer that's part of App Engine, that dispatches all of your calls to back-end services, has assumptions about the environment that it executes in. So I've got an example up here that I've taken from the implementation of the data store API. And you can see this call, API proxy get current environment. If it's not there, it throws a null pointer exception. The data store API assumes that either the dev app server or the application server that's running in production is setting up a current environment for it. And if it's not there, it's going to throw an exception. But so what happens when you're running a unit test or an integration test and there's no dev app server to set this environment up? You're going to get this exception, the null pointer exception. So what are you going to do? Well, if you've been writing unit tests on App Engine for a while, you probably remember originally you had to jump through a bunch of hoops to make this work. You had to implement a bunch of interfaces that sort of seemed like they were part of the implementation, and it was just dirty and messy. And then a couple releases ago, we released the App Engine testing APIs, which make this much, much, much nicer. So I want to show you a quick demo of using the App Engine testing APIs locally. And we're going to go back to our favorite little App Engine demo app, the Guestbook, and we're going to write an integration test for Guestbook. Oops. Not ready for that yet. OK. So this is not your typical Guestbook application. It looks the same. You've got your shout-outs. But the interesting thing about it, actually, let me show you that application real quick. While that comes up. The interesting thing about this version of the Guestbook application is that it supports higher availability rights. So when you give it a new message, it will try to write it to the data store. And if that put into the data store succeeds, then everything is good. But if it fails, it's going to queue it up in a task queue task to execute later. So we get eventual consistency with our data store writes. Now, I want to write an integration test that verifies that this works the way that I expect. So I'm going to write two tests here using the local testing APIs. The first one is going to test that synchronous writes behave the way I expect. The second one is going to verify that asynchronous writes work the way I expect. Let's get a little screen real estate here. So I'm a little bit old school. I use JUnit 3. So I'm going to extend test case. And the very first thing I'm going to do is make sure that I've got the App Engine testing APIs configured properly. So I'm going to get a local service test helper. I'm going to instantiate that. And since this test uses the local data store service and the local task queue service, I'm going to instantiate some configs for both of those to tell the test helper that I want to use both of those local services. That's the one for the data store. OK. So I've got that allocated, and now I need to override my setup and teardown methods to make sure that the helper gets set up and tear down as well. There's the setup. We'll tear it down. Symmetry is good. OK. I'm ready to write some tests. There's a couple of helper objects that I think I'm going to need. I'm testing a guestbook DAO, data access object. So let's get a hold of one of those. And we'll get a hold of a data store service as well, because I'm going to use the low-level data store API for some of my assertions. Data store service, great. OK, I'm ready to go. Got my object set up. So the first test is going to be testing synchronous writes. Signature of this method is DAO save. I need a greeting object. So I'm going to rely on a helper method that I have sitting around. New greeting, hello IO. And we'll save that. And if we look at the implementation of this method, you can see that one of the things that I'm doing here is setting the key back on the greeting once I've saved it. This is the indication to the presentation layer that this was a synchronous write, because I got a key back. I got a unique ID back. So let's verify that I got a key. Assert not null. And let's also make some assertions that the data actually found its way into the data store. So I'm going to use the low-level API to look this thing back up. Data store service.get, greeting, look it up by its key. Now this will throw an exception if it's not found, entity not found exception. That's fine. I want this test to fail if it's not found. So I'm not going to bother catching this exception. I'm just going to let it propagate out. And then finally, I'll assert that the content is what I expect. OK, this looks like a reasonable test to me. I think I could sleep at night. There's probably a couple extra things that I would do if I wasn't typing it live in front of all of you, but let's see if it's green. OK, it's green. I'm happy about that. But let's try the more interesting example, the asynchronous writes. In order to test that asynchronous writes are working, I need to force the data store to fail. The way that I'm going to force the data store to fail is I'm going to create a custom delegate object. A delegate object is an object that all of your RPCs pass through en route to the back-end services, whether you're running in production or whether you're running locally. So in this case, I'm going to create a custom delegate object that will throw an exception on every data store RPC. So I'm going to call this an explosive delegate, and it's going to extend base delegate, which is a helper class that I've defined. There's not a lot going on in here. It's really just delegating for all of the methods, just trying to save some typing. The one method I want to override is make synchronous call, because I am making a synchronous call to the data store, and I want to intercept that. So I want to see that if the package is data store v3, this is a constant that is defined. So it's sort of a magic value, but it's a publicly accessible magic value. It's accessible to everyone here. If it's a data store call, I'm going to throw an API proxy exception with a specific error code, which I want to import. Internal error. Okay, that line's a little bit long. We can split that up. So any data store call that comes through here is going to generate an exception. The next thing I want to do is intercept all the calls to the task queue. The reason I want to do this is because I'm going to capture the message that I'm sending to the task queue so that I can make some assertions about it. So I need to declare a member, so I have a place to put it when I actually catch it. And so this is a bulk add request. And when it's a task queue message, I'm going to merge that. I'm going to populate that value. These are protocol buffers, so I'm just going to take the raw bytes and fold them in. And then I'm going to let the call flow through. So I've got a custom delegate here, which I can use to assert that when the data store throws an exception, I then get a task queue message. And I'm going to capture that task queue message, and then I'm going to make some assertions on it. So let's write the actual test that installs this delegate. The first thing I need is an instance of this delegate. And then I'm going to install it. This install method is something that's in that base class that I didn't want to type out in front of everybody. But it's 2 lines of code. It's just setting a global variable, holding on to the original value. And I know I'm going to want to unset it later so that my test doesn't leave weird state around. So I'm going to do all of this in a finally block. Uninstall. And then we're going to do something very similar to the original test. Oh, hi. Except instead of asserting that the key is not null, I'm going to assert that the key is null, because this is the indication to the presentation layer that this was an asynchronous write, so that it can display something appropriate like, we got your message, it'll be there shortly. And then finally, I want to make assertions about the greeting that is actually encoded in the task queue message. And I have a helper function for that that's going to help me with that. I've got my greeting, and I can say demo helper. Please extract the greeting from this task queue message. Bulk add? Yes? No? Oh, I forgot to make it a member. There we go. OK. OK. So now I have something that's checking that there is no key at the conclusion of the write, and also checking that the greeting gets properly encoded in the task. And again, I've got a test that passes, and I feel reasonably good about this. This is pretty decent test coverage for this. Ordinarily, I'd probably want to verify the individual attributes of the greeting to make sure that they got translated properly. But for live demo purposes, I'm satisfied with this. So let's move on. That was the local testing API. What I hope you noticed was that I did a little bit of setup at the beginning to install the test helper. And then everything else was pretty standard unit testing, integration type stuff with a little bit of extra knowledge of how the RPC layers work. So let's move on to the fancier stuff. Do you want to run your tests in the cloud? I want to run my tests in the cloud. I want to run my tests in an environment that is as realistic as possible. And we've done a really good job making sure that the dev app server has equivalent functionality, but there is no substitute for the real thing, functionality-wise, also performance-wise. Right? The local data store service stores everything in memory. You're not going to get accurate latencies for writes and reads unless you're running things in production. So fidelity is really an important reason to run your tests in the cloud. The other reason, though, is efficiency. If you've got a really large test suite, Google App Engine has all of these computing resources that are at your disposal. So rather than sitting there waiting for your test suite to run for 30 minutes or an hour, or however long it's going to take, or biting the bullet and deciding to set up your own test grid, which you're then going to need to maintain, upload your test to App Engine. Run them there. We will manage your test grid for you. So what are the similarities between the types of testing that you're used to doing in cloud testing? Again, your frameworks work. Your best practices work. End-to-end testing. In this case, we're just driving things through the front end of your application. The front end of your application is available on App Engine the same way the front end of your application is available when you're running locally. So that's the same. Again, this is really good news. What's different? There are more differences here. First and foremost, your tests are now subject to the requirements we have for App Engine requests, which means they need to finish in 30 seconds. They have to obey the sandbox restrictions. So if you have tests that like to communicate directly with the network or spin up threads or do any of the other things that we don't let you do in the cloud, that's going to pose a problem. Now, I don't have any good solutions for those two issues. Your tests still need to finish in 30 seconds, and they still need to obey the sandbox restrictions. But this third one here, that you have to invoke your tests over HTTP, I do have a good solution for you here. I have a framework called GAE Cloud Cover, and it just went 1.00 final last night, and now it's at 1.01 final because I found a bug this morning. But I'm releasing it, and its sole purpose is to help with this issue. How are you going to run your unit tests and your integration tests over HTTP? Test harnesses typically assume that they can communicate with your code in process. But when they get to the cloud, that's no longer possible. But Cloud Cover is going to help with this. We're going to push your tests into the cloud. We're going to install Cloud Cover along with it, and through the Cloud Cover UI, we're going to drive your tests. So let me give you a demo that's going to illustrate how easy it is to take the test suite that we just built and deploy it to the cloud. The primary design goal of Cloud Cover is to run existing test suites. I don't want you to have to retrofit everything that you've already done to run in this specific environment. I want your tests to run locally just as well as they run in the cloud, and vice versa. So if you want to get your tests running in the cloud, I've listed the steps here. You're going to install a jar. I'm not going to show you how to do that. You're going to configure a servlet. It's fairly boilerplate. The documentation describes it nicely. You are going to replace the local service test helper with Cloud Cover's own implementation of the local service test helper. And the reason for that is that the local service test helper that I showed you when I was writing those tests assumes that you're running locally with local services available. But when you're running in the cloud, those local services aren't available. So we want to install Cloud Cover's version of this, which is really going to turn those initialization steps into no-ops, because everything that you already need in production is there. You don't need to set up that current environment. You don't need to mess with the data store. Then we're going to write one small class, which is going to tell Cloud Cover about the test suite that it's going to run. We're going to deploy, we're going to run, and we're going to feel good. Whoops, before we get to that, let me show you the demo. So what do you think, Alon? Live or offline? Go for it. Let's see what happens. So I have this very simple demo queued up here. This is the Cloud Cover UI. I'm going to click Start New Run. And looking good. OK, so it ran extremely fast. There are only 3 tests here, and it shows a failure. Ooh, and I got a little XMPP message saying, hey, your test run is done, which is not that useful when it takes 5 seconds. But if it takes an hour, that's nice. And this happened to fail because I included intentionally a failure message, just to show you what a failure looks like. But these are the tests that we just wrote. And I uploaded them before I came up here. So test async write succeeded, test sync write succeeded. And this is sort of a poor man's version of what a testing UI looks like in your IDE or something like that. But it's on the web. Now, there's something interesting going on here, though. I've seen at least 2 other web test runners which appear to do something similar. And some of them are really gorgeous. They have these unbelievably pretty UIs. One of them is called Katori JUnit WebRunner. And I just found out about it this week, and I need to talk to that developer to see if we can collaborate, because their UI is absolutely gorgeous. There's a link to it that should be in the live wave when we're finished. But Cloud Cover is doing something a little bit different. We're running your tests in parallel using the task queue. We're creating one task queue task per test, and then we're letting the workers run through them. So here's an example of what's going on. When I click that Create New Run button, the tests are loading up in the suite. The tests are being fed into the task queue, and then once they're all fed in, the workers start chewing on them. And this is all asynchronous, which means we can do things in parallel. And when we're done, we get that nice little XMPP notification or email or however you want to get your notification. You can configure it, and you get the results of your test suite. There are some additional things we need to think about when we want to run our tests in the cloud. Isolation. How many people have ever run an existing unit test suite where the tests run in parallel? Googlers, right? Because we have a framework that does it for us. OK, not a Googler? Good. OK, great. So it gets more complicated, right? Your tests are now interacting with one another in ways that you didn't expect. So this first example up here, let's say we have two tests, one which deals with a read-through cache, which when you ask it for a value, if the value isn't there, it then turns around and asks the data store for it. And then you have some other test, which is just a simple query, right? Feed some data into the data store, issue a query, make sure that what you got back is what you expect. You wouldn't expect there to be any interesting interactions, but if we wrote that explosive delegate that I showed you in the earlier example, and we installed that, that explosive delegate is global, which means that if these two tests happen to hit these two same points at the same time, the test that's just verifying the simple query is going to blow up, because it's going to try to do something that talks to the data store, and that explosive delegate is sitting there. And it's going to throw an exception, and you're going to scratch your head thinking, what went wrong? This didn't happen last time. And now you've got flaky tests. Another example that we need to think about here is that your test data needs to be thread safe. And I put that in quotes. In these examples here, we might have one test that creates a user, another test that deletes a user. And if they get to these 2 points at the same time, where the creation test is asserting that something exists after the deletion test has gone ahead and done its deletion, again, we're going to get a test failure in a way that we didn't expect, right? We're looking at test create user, and it failed, and we said, well, we created it, and then we tried to read it back, and it's telling me it's not here. What happened? Well, this other test deleted the data out from under you. So non-thread safety gives you flakiness, and flakiness can be really frustrating because it's difficult to reproduce, and even if you do reproduce it, you might not reproduce it in the exact same way. So we need solutions to these problems. Here are the solutions to these problems. These are both part of Cloud Cover. For the delegates, we have an alternate delegate implementation that you will need to retrofit your tests with. It's a thread-safe delegate. So the example that I showed you at the beginning, instead of installing that delegate globally, we will use a thread-safe delegate so that that change will only be visible to the thread that needs it. That's going to take care of it there. We do have to make that change to our code, but it's a pretty minor change. The other solution is very cool. We have a feature coming out shortly, if not in the next SDK, then probably the one after, called namespaces. And this is a way to stripe your data. This is a way to scope your data so that you can perform some work within a certain namespace. And the work that you're doing with, say, the data store or memcache, all of that persistent state is associated with that namespace. So we can isolate the data of different tests from one another. And this is exactly what Cloud Cover does. Every single test that's running has its own namespace. So in the example that I showed you before, when we say that we are creating a user and then deleting a user, and some other test is creating a user and then verifying that it exists, even if from the application's point of view, those entities are identical, they're not going to overlap. So we've got our data isolation, and Cloud Cover is going to take care of this for you. Thank you. So let me show you an example of this actually working. The demo that I showed you before, that was a talk demo. It was very small. But I want to show you something real. And I figured what better way to show you that this is real than to run a real test suite in the cloud using Cloud Cover. So I've taken the test suite for the JDO JPA implementation that ships as part of the Java SDK. It's about 1,300 unit and integration tests, and it does all of the hairy stuff you might ever imagine a test suite could do with the local data store. Every type of query you can think of, installing custom delegates left and right, this test suite does it. And so that's what I'm going to run here. I will select it from my dropdown. This test suite is called Data Nucleus because the test suite is built on the Data Nucleus Access platform. And I will start this running. This will not run as fast as the test that I just showed you. I'm running half the test suite because I do want this to finish while I'm still up here. It does take some time. This is an example of testing in the cloud for fidelity as opposed to efficiency. Almost all of these tests are doing lots and lots and lots of data store interaction. Locally, it will run faster because the local data store is completely in memory. It will run slower here because it's using the real data store. It's actually communicating with the backend data store. But I do get the true experience of running this code in the cloud. So this is the test suite that we run before we release a new implementation of the JDO and the JPA. And as we can see here, it's going along pretty well, actually. It's at 34%. You'll notice that there's this item here, too slow. There's 148 tests that are too slow. These are the tests that aren't finishing in 30 seconds. At some point, I need to decide whether I want to break these tests up just so that they pass on Cloud Cover. I might do it because I really, really would like to run this in Cloud Cover and see all green. I haven't seen it yet. There's still a few interactions that I haven't sorted out. But by and large, this is working. You can see it clicking away. We've got 68 tests that are running in parallel right now. Let me show you in the admin console, maybe, what's going on behind the scenes. Come on, yes. All right, so we can see our traffic spiked up a little bit. But all of the real work is happening in the task queues. You can see we've got 32 tasks in the queue. We've run 1,200 tasks in the last minute. And I can look in here, and you can see that there is one task for every high-level test case that I'm executing. And so the workers are just clicking their way through. I've configured my, my default queue to have the maximum rate, because I want to get through these as quickly as possible. The maximum rate is 50 tasks per second. These tests aren't that fast, so I'm not actually scratching that limit. But I'm going to show you something in a little bit that definitely makes use of that. So let's go back. Let's see how we're doing here. We're 93% done. We're just about finished. Yep, there it is. OK, cool. So that was the fancy demo. And that should convince you that this is real. That really is the real test suite doing all sorts of hairy unit and integration testing stuff with App Engine running in the cloud. And it ran still pretty quickly, even though it was using the real data store. But let's take this a little bit further. Everything I've shown you so far has involved running App Engine test suites in the cloud. But why limit ourselves? The Cloud Cover framework is agnostic. It doesn't care whether or not your code under test uses App Engine. It doesn't care whether you're using JUnit or TestNG or which version of JUnit. It's a little bit of work you have to do to plug in a different test harness. But the framework itself is agnostic. So if you have a large test suite, even if it's a test suite for something that is not App Engine, why not upload it and let App Engine be your grid? So let's do an arbitrary demo. Arbitrary code. The Google Collections framework. If you're a Java developer and you're not familiar with the Google Collections framework, check it out. It's really, really useful. That's the end of the plug. This is data structures. Okay? It has nothing to do with web apps. It doesn't know anything about the data store. It was built long before App Engine ever existed. These guys have 44,000 tests. I'm not going to run 44,000 tests. I can't get 44,000 tasks into the task queue in 30 seconds. If I could, I would go for it. But I am going to run a bunch of these tests. These tests have absolutely nothing to do with App Engine. So I have uploaded that test suite. This is the Google Collections test suite. And I'm going to start the run. Now, this initial request is slow. This library does a lot of dynamic test generation. It's working really hard. These folks didn't actually write 44,000 tests by hand. They have a number of template tests, which they're using for different map implementations and different list implementations. And they have ways of generating tests for the different implementations of map and list that they're providing over and over again. So they kind of exploded out. But I'm running, I think, 2,400 tests here. And this is humming along very nicely. I've already finished 1,500. This thing's going to be done very quickly. I've got a failure, the suppliers test. Let's see what's going on there. Oh, it's already done. OK, that was fast. I look at this failure, and look what's failing. Test thread safe. Well, that shouldn't be too much of a surprise, right? I told you up front that if you're going to run your tests in the cloud, your tests and the code under test have to abide by the restrictions of App Engine. Here's a thread safety test. They're spinning up threads. I can't run this test on Cloud Cover. But this work will get done. We will take care of it on the Python side. We need to hone in on what the exact expectations of Python developers are. Running tests inside the local sandbox. This is kind of a big one. Those tests that I showed you, those integration tests that I was running locally, weren't running with any of the security restrictions enabled. I could have written, if the code that I was testing did something that wouldn't run in App Engine, like spin up a thread, those tests still would have passed. It wasn't running in the secured JVM. It was running in a raw JVM. So we need to figure out how to do this. We want as much fidelity as possible, whether you're running in the cloud or locally, and part of making it a proper emulation is enforcing the security constraints. When you're running your application in the dev app server, we've got that working, but when you're testing, we don't have that working yet. I tried to do it in time for this demo. Couldn't do it. It's hard. We need to figure some stuff out. So we'll get to that. And then there are certain types of tests where you want to launch the actual dev app server and throw some traffic at it. Or in the case of the integration test that I showed you, when we were trying to figure out what happened with the task queue and we were extracting that greeting object from the task queue, you might have been looking at that and thinking, well, rather than asserting on this sort of these low-level bytes that are passing through the RPC layer, why don't you just pause for a bit and wait for the task to execute? The reason is we're not in a good position to actually write that test yet. The local task queue implementation uses the URL fetch service. Right? That's how tasks work in App Engine, is that you give it a URL to hit. But in order to hit a URL, you need to have an HTTP server running, and we don't have that yet. So we need to find a way to make that much easier to do so that you can write those types of tests in the most natural way. For Cloud Cover, there's lots of really interesting work to be done here, and I think we're just getting started. And the cool thing is that it's completely open source. There should be a link on the live wave, if not now, then shortly, that shows you where you can download it. And if anybody wants to help out with this, I've already got a bunch of feature requests filed. If you've got your own ideas for what it should look like, that would be cool. If you want to make the UI look as beautiful as that other one that I referenced before, that would be cool. Jump in. So the conclusions that I want to take, that I want you to take away, first and foremost, developer testing is important. If you didn't believe that coming in here, I hope I've convinced you to at least take a good look at it. Mitigating that risk as your project grows can really, really make a big difference in the long run. The other thing I hope you see is that everything that you already know about testing transfers to App Engine. This isn't a case where you need to unlearn things and learn a totally different skill set. If you know how to write testable apps already, you know how to write testable apps on App Engine. If you know how to write effective tests already, You know how to write effective tests on App Engine. You just need to become familiar with a couple of the technical details that are specific to App Engine. When it comes to local testing, use the App Engine testing API. It's going to make your life much easier. And when it's time to run your tests in the cloud, use Cloud Cover, push your tests inside the cloud, and let Cloud Cover drive it. Finally, remember that even if you're not a web application developer, you can still use App Engine. App Engine is good at fan-out. It's not a general-purpose computing platform, but it's really good at web applications, and it's really good at fan-out. And if there is a fan-out element to what you're doing, like with testing, here's a test suite. It's made up of individual tests. They don't know anything about one another. They're not related to one another. That type of problem can be very effectively solved by App Engine. So keep your minds open. And now let's do some questions. OK. And feel free to ask live questions as well. So the number one question on moderator, I'll get to you in just one second. The number one question on moderator was, is this talk Java specific? I hope not. Conceptually, this all applies, right? If you want to write Cloud Cover for Python, you could do it today, except for the aspect of the namespaces not being available yet. But you can write all of the code. It just won't necessarily run if you're using the data store or memcache. So apologies to anyone in here who felt misled. Let's take a live question here.
So one of the challenges with data-driven testing is one challenge is isolation.
Yeah.
The second challenge is the data setup portion, where you have tools like DB units. How do you do that in App Engine? Because
you were asking the hard questions at the fireside chat yesterday too, right? OK. My personal approach is for unit and integration tests, I try to operate on a fairly limited data set that I can set up easily within the 30-second limit. I'm not uploading megabytes and megabytes of data that I then assume the existence of across multiple tests. I've been on projects where we did that before. We ultimately moved away from it because you find yourself in the position where you need to restore that data to its original state, or you find yourself in the position of pretending to commit transactions and then rolling them back, but things sometimes fail when you commit and you miss out on the opportunity to see those errors. So my approach is, try to write tests that operate on limited data sets. I know that's not always practical. If you find yourself in a position where you do need a large data set, testing that in the cloud right now, that's going to be a challenge. But very good question. Yes?
I noticed you didn't use dependency injection. What's your take on dependency injection?
I love dependency injection. I've used Juice a lot. I've used Spring a little bit. We don't do it as part of the SDK because we don't want to force any frameworks on you. We want you to bring your own frameworks. So in that particular data access object, perhaps you caught that I was initializing private final members in line. And that would be a smell in my own code. But in terms of keeping things short for a demo, that's the way I initialized it. But in general, I should back up and say, I don't think dependency injection is necessarily important. I think inversion of control is important. And dependency injection, I think, is a very effective way to get inversion of control. Didn't want to introduce any additional frameworks here. And just as a team, our general approach is we want to let you choose the frameworks that you want to use. So that's why you don't see Juice as part of the SDK or Spring as part of the SDK. That's your choice. We don't want to force that on you. OK, let's see what else we have on moderator. Any integrations with C, continuous integration servers like Hudson for testing monitoring? So no, but all of this can totally happen. Right? This Cloud Cover it's not nearly as full-featured, but the idea is very similar to something that we have running internally at Google that we use to run our tests. And in addition to running all of our tests, we have data repositories that keep track of the history of our test runs. And we've got all sorts of good analytical data. So all of this could happen with Cloud Cover. I can't think of any reason why Cloud Cover can't be the external version of this thing that we have running internally, which is incredibly useful in terms of integration with IDEs, integration with other servers, reporting, metrics, all of these things. You could even imagine going so far as to have an online performance regression framework, which would be incredibly useful. That sort of thing is so difficult to set up, but so valuable once you have it. So, to answer the specific question, no, that integration doesn't exist. But I think all of these things are possible, and I would love to talk with anybody who's interested in pushing it in that direction. Live question.
Hi. Is the App Engine testing API also Java specific, or does it?
The App Engine testing API is currently Java only, and that is the thing that is the thing that I want to rectify.
Yeah, because we'd love that.
Soonest.
The Python programmers would love that.
Yeah, I mean, don't get me wrong, you can write tests for Python. It's just these libraries wrap up sort of some of the messiness. Yeah. Yes?
Hi. If I have to execute a pretty heavy multiple thread test, stress test, so should I let Google knows beforehand?
So if your test is similar, if your test is a load test, then we have, in fact, there was an I/O talk 2 years ago, which should still be online, by a fellow named Ken Ashcraft, who talks about load testing strategies for Google App Engine. So the general piece of advice is ramp up slowly. Don't turn your traffic on like a brick wall, right? If you look at your admin console, it should ramp up as opposed to just being a giant step. And beyond that, I would recommend looking at that talk. There's really useful strategies there.
Okay. So is there any cap or there's some?
Well, it's just traffic to us.
Number of the
right?
threads?
It's just traffic to us. So we can't distinguish between a load test and traffic.
Yeah.
It's your app's getting traffic. We don't know what you're doing.
Okay.
Enable billing, that will help. Yeah, thank you. Yes.
Hey, thanks for your talk.
Sure.
So I've been running tests in parallel in sort of a cloud-like environment for about 8 years, so it's good to see other folks doing this around App Engine now.
Good.
You said you wanted to take tests that run fine locally and parallelize them.
Yeah.
But then it seemed like you had to make a bunch of changes to them. There's this delegate thing and this JUnit 3 config thing. And so does that mean that once you've done that, they no longer run locally? Or how do you, because you really want both modes.
Right. So the changes that you have to make, and let me just show you, because I skipped over this part of my demo because I was working on time. So to answer your question, once you make these changes, do they still run locally? Yes, they absolutely run locally. These Cloud Cover implementations of these classes that you're swapping things out for can distinguish between a local run and a cloud run. So if you're running locally, they do the thing that they're used to run. They do the thing that they normally do. And then if they're running in the cloud, then they do this slightly different behavior. So for this test that I wrote here, which was the guestbook DAO test, there are 2 changes. Here's the first one. Okay, that's the first one, which, and if this was for example, in the JDO JPA test suite, this helper setup is in one base class that everything extends. So you don't have to go through. I didn't have to go through and change it in 300 different places. The other thing that you have to do is change the delegate. And that's in this base class down here. Where's install? Okay. And in this case, I didn't rehearse this part, so I have to find my way through it. But it is the Cloud Cover local service test helper set delegate. Actually, so the first thing we do here is we're going to replace that, and we're going to replace that, and that's it. That's really it. So it's still pretty compatible. It is true that your test suite is going to have a dependency on cloud cover. It's a really small jar. I don't think it's really going to get in your way. There you are. Does that answer your question? Okay. Yes?
Are there any Selenium-style test suites coming for visualization?
For visualization. I don't think I understand. I'm sorry. I know Selenium.
I'm sorry, for UI testing. It's a related question.
Okay. I think it ties into the thing we want to make better, where we want to simplify the process of running tests that fire up the dev app server. That will make that sort of testing easier. When it comes to running these tests in production, Selenium just wants to know what URL to hit, right?
You can actually test click-through scenarios with Selenium scripting.
Yeah.
So I was wondering if Google was going to release anything that's App Engine specific, so that we could test UI and visualization on App Engine.
Okay. We don't have any concrete plans, but let's talk for a minute afterwards, because I have a feeling that I'm not fully grasping. Okay. Yeah.
I have a very similar question.
Sure.
Is there any plans to, or is anybody building a load testing kind of application on App Engine which can do fan out, like bus computing and
Where the load is generated by App Engine?
App Engine, and perhaps test something? I mean, I'm sure that you have a lot of applications which runs on web scale.
I'm not aware of anybody building that. Okay. Could be interesting. Yeah. I could take another question from moderator. Will testing.api be available for a modern language? Ouch. If you consider Python a modern language, and I do, I don't want to start any fights, then yes, it will be available. It still hurts, though. Does local memory data store persist collections using helper using JDO JUnit? Sorry? All your tests are failing? Your collections never come back when you're using JDO in your testing? I'm sure I could help you diagnose it. There is a blog post that I'm planning for my blog, which deals largely with recipes for JDO and JPA, and there is a testing entry long overdue. So when that entry comes out, I'm going to show you exactly how I do it. The other thing you can do, though, is all this test suite for JDO and JPA that I ran using Cloud Cover is also completely open source. And you can download it, and you can type ant test, and it will run. And so you can see 1,300 examples of testing with JDO and JPA, and there's lots and lots of collections tests, because it's hard to get right. Yeah.
Is the namespace feature you mentioned applied to the Memcache service as well?
Yes. Data store and Memcache are both namespace aware. I have not tested Cloud Cover with Memcache tests yet. I would not be shocked to find that I'm doing something wrong, but I will test it before this namespace feature becomes generally available to make sure that when you can use all of these features in App Engine, you can also use all of these features in Cloud Cover. I think there's one last question here. Can you do isolated end-to-end testing on the local GAE server? I'm not sure I know I'm not sure I know what is meant by isolated. Is that referring to sort of data setup and teardown? I don't know. Okay. So thank you all for coming. I really appreciate it. And stay tuned for the next talk. Alfred's going to be talking about next-gen queries, and it's really cool stuff. So please stick around.